Pretty exciting stuff. What do we know about x-intercepts?
They go on the x-axis.
They do. What's the y value? Okay, let's start with that. They got different names. They're called roots. And what's the other name?
Zeros?
Zeros.
Oh, I remember that.
So if I'm asking for x-intercepts, roots, zeros, I'm really asking for the same thing right across the board. What is the y value? What is the y value on your x-intercept?
I mean, it's like where it peaks, like a parabola.
You're talking parabolas. I'm talking about if I had a parabola and I want my x-intercepts,
Oh, vertex. A y.
I want these. What's the y value when you hit the x-axis?
Oh, it's zero.
Zero. That's what I was. So we know we find the x-intercept when y is equal to 0. Okay? Really not, this shouldn't be new, but this, ladies and gentlemen, is the most important. These are the most important points on an absolute value function. Okay. Super duper important. You have to solve for your x-intercepts. So we're either going to do that by algebra or factoring. We know when to do what. Next is our y-intercept. We only have one of those. And x is equal to 0, right? Everybody good with that? Nobody's crying. This is a good thing. Piecewise function. You've never heard of this before. Piecewise function.
Wise function.
Piecewise function.
Because it has absolute value brackets on the side.
It's what happens. So the piecewise function is a domain statement. Does everybody know what I mean by domain statement?
I think I have an idea.
Like, if I asked you for the domain of something, you can go from this point to this point,
Yeah.
right? Domain statement.
Is that from like 6.0 set notation or?
You could do it in set or interval notation. You would have done it in grade 10 intro, and then now I just expect you to know it, and now we're going to make it more complicated. Yeah, we did it too in,
Chapter 4?
First unit
Or 3?
second unit.
when did we do the in unison with? The U. We've done those, haven't we?
That
was
quadratic
something.
function.
Wasn't that fun? No, we didn't graph radicals yet. I thought anyway, we'll get there. Broken into 2 parts. Okay, so I'm going to ask you to break down your domain into 2 parts. And that's why it's called a piecewise function. And it's always related to the domain. So I'm going to ask you to write me a domain statement about which things we evaluated as absolutes, and then which stuff belonged to the original.
That's a LX, right?
F. It's my cursive F.
Oh, F.
It's as good as I
A
get.
second cursive.
It's okay. I'm doing my best. And you guys are going to do these on linear graphs, and you're going to do them on parabolas as well. Get yourself some erasable pens or do everything in pencil. All right. I think the easiest thing to do when I'm graphing an absolute, and you know that this is an absolute function because it has the absolute brackets, is I want you just to ignore that. I had an erasable pen out here just recently. I don't know where it went. I want you to just look at this graph for a sec. So I'm just dropping the absolute. So I'm going to refer to this as the original graph. So when I'm talking about that piecewise function, the original part, I'm looking at this just linear equation. You guys agree with me that this is a straight line? Okay, good. I like it. I like when we all agree on this stuff. I want you to find the x and y intercept of this.
Y would be the negative 3.
Easy peasy. Y,
Oh, so is it positive?
nope, it's negative.
Which one was it where we had to flip the sign?
It's when you're solving it. It's when you're solving it. So when we solve for x here, so when we're solving for our x-intercept, that would be 0 equals 2x minus 3. And this one would have been f of x equals 2 times 0 minus 3. So that's how we got the -3. And this one, when we solve it, x is going to be equal to 1.5, or 3 divided by 2, however you choose to see it. Maybe it's better if I do 3 by 2. Does that make more sense? We're going to bring the 3 to the other side. It becomes positive. We'll divide out the 2. Okay? What did I say was the most important point on an absolute value graph?
X-intercept.
The x-intercept. So that's super duper important. All right. Can we do a table of values for these? Or do you want to just graph it using slope point form? Like by the slope? What do you guys want to do?
We can do slow, I think.
We can do slope? Okay, there's no increments on this graph, ladies and gentlemen. So I got to put some on. Do you guys skip and do like every second one or every 5 or something like that
And what?
when you're putting them on?
We usually skip count, like we'll go 2s and then 4s, but we'll like skip count it to 4 or 8, like each, but we still write out every single number.
Okay. You can also do this by graphing intercepts. How do you feel about that? No? Nobody has an opinion? So my intercept, my y-intercept is at -3. And my x-intercept, we said, was at 1.5. And that's good enough. But do you guys want to do table of values maybe? Or more points than that maybe? That might make sense. So what's my slope? My slope's 2 over 1. So if I start at -3, I go up to over 1, up to over 1, up to over 1. I'm going to go down 2 and 1 to the left, just to give me some points on this side. And if I put my handy dandy ruler on here, now that's a linear equation. That is from grade 10. That's super easy. What is going to make this an absolute value graph? What do absolute value?
All the negatives.
What negatives? Y's or X's?
X's? Not
The
Y's.
Y's. So I'm going to create a table of values just because I can. So if we were to do XY of the original graph, at -2, I'm at -7, -1, I'm at -5, at 0, I'm at -3, at 1,
I'll remember this. Move the same on both sides.
Okay. Right? You guys agree with me? And how we calculated these, like if I put these into the equation, y equals 2 times -2 minus 3, that gives me my -7, which is right there. Everybody agree with that? Yeah? But now we got to turn it into an absolute graph. So the absolute graph was f of x equals absolute of 2x minus 3. You guys agree with me there? So when I do my table of values, my x's can be negative, but my y's, when I substitute a -2 in here, I'm going to get an absolute value of -7. What's the absolute value of -7?
7.
There's 7
Just
times
7.
This is because it's like the dependent variable.
Yeah. Okay, so if it was negative 5, what's the absolute value of negative 5? 5.
And so
Negative 3 becomes 3. Negative 1 becomes positive 1. What's the absolute value of 1? Just 1. What about the absolute value of 3? Just 3.
So that's all we have to do?
Okay, so what does this graph show me? This is the original, right?
That graph's.
So really what happens on these is that these negative y values
Just go over.
can't exist on the absolute, right? So what happens to them?
They vanish.
They flip up, right? It's just a reflection in the x-axis. It's like I have put a mirror here. This negative 1 becomes a positive 1. This negative 3 becomes a positive 3. Negative 5 becomes a positive 5. My x's don't change, but my y's become positive. All right. So now, remember when we were learning how to do parabolas and I said make sure you have that smooth curve as you go through the vertex? It can't be a V because a V is an absolute value graph.
Oh my god.
Well, you are here now.
I remember that from a long time ago.
So, this is your absolute value graph. The yellow part, that whole thing, is what your absolute value graph. The reason why the x-intercept is the most important point is because it's the last place that y is 0. Anything under that is going to be negative. So that x-intercept is super duper important. Okay, look at us. We just graphed an absolute value graph.
Makes a big Y.
We need to get rid of this.
Oh.
Because this can't exist. This
Looks-
section here can't exist.
It looks like a big Y.
It does look like a big Y, but it's going to look like a big V, right? I'm going to leave this on here just for our training wheels, just to remind us that on the original, this part can't exist, and we flipped it up as a reflection in the x-axis. Okay. I've left myself no room to do domain. Let's do it piecewise. Let's do domain and range of the function. What's the domain of this function?
0.
Nope.
Negative to the 4.
I put arrows on this.
So it's
Oh,
infinity.
negative infinity and positive.
Just like your domain on that original linear graph would have been negative infinity to positive infinity, it's going to stay the same. What about range?
0 to positive infinity.
Correct.
Oh, I was thinking of range.
That is what we're doing. So the range, the lowest we can go is 0, and the highest we can go is positive infinity. We know because it's an absolute value graph, we're going to have no negative values in range. We'll get a little bit more into this when we start doing reflections and stuff, and you will do this in grade 12, and they will expect you to have remembered absolute value functions. So do what you will with that piece of information. Now this is the hard part. This is going to be the thing that kicks your butt, is the piecewise function. So the piecewise function is where we break the graph down into the original. Which part was part of the original function? Please note that I've done them in different colors. Is it the pink or is it the blue?
Well, the original was the thing.
The original one was pink. So we know that this arm of the graph belongs to the original. And what part of the graph did we flip? The blue part, right?
Yep.
So this is the thing that changed with the absolute. So the yellow makes up the entire graph, but really there's parts that we did stuff to, like the absolute value changed this part, it flipped it up. So we're gonna break it down into 2 domain statements, super easy. So our piecewise, so for our absolute, so I'm gonna start with my absolute value, just, I'm taking the function and which part flipped. Give me the domain for the part that flipped. Give me the domain for the left-hand side of the V. And it's a domain statement, so we're dealing with
1.5, well, negative 1 to 1.5,
-1?
or negative 2.
Nope, got an arrow on it.
Oh, negative.
So negative infinity to my absolute value, to the 0, my x-intercept. This is why it's the most important point, because this is where it kind of switches. So where is my x-intercept?
1.5.
1.5. Now, in the absolute, we always say it's a round bracket.
Oh. Even when it's a number?
Yep. Because when I go to do my original, which one? The blue part. Give me the domain statement for the blue part. Where are we starting? 1.5. This time it's inclusive because what's the absolute value of 0? 0. It's not, it didn't change, right? So it gets included with the original. And where are you going to? Positive infinity. So this here, as I've crammed it in at the top of the graph, is the piecewise function. That's all you're doing. Making a statement about what flipped and what stayed the same.
Wait, why did we have a round bracket again?
Because at 1.5, the y value is 0. And when you take the absolute value of 0, 0 is neither positive or negative. So it stays, because you didn't change it. When you put absolute value brackets around it, it didn't change here in our table of values. Okay. Kind of confusing, but it's okay. I guess like not really, but all right, here we go. We're gonna do it on a parabola now. Isn't hard, because we've done 1,000,000 parabolas. We've done 1,000,000 of them, so you're skilled in them, but I always look at the original function first. That's a terrible negative x squared. Just jamming it in there. Who filled in for me on Friday?
Mr. Tim.
All right.
Wait, it stays as a negative when you go? Oh, yeah.
All I'm looking at is the original, and when I look at the original, I'm just dropping the absolute value brackets. I'm going to treat it like it's a chapter 3, 4 question.
Okay.
Okay? So what do we need to know when graphing a parabola?
What do we need?
What do we need?
X-intercept, Y-intercept.
And?
The vertex.
The vertex, most important point on a parabola. And which way does my graph open here?
Down.
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 It's negative X squared.
Okay. So let's find our vertex.
2 and negative
X equals negative b over 2, right?
So we'll use our secret formula. Everybody got 1, 9? That's what I got. So let's do our y-intercept next. That's nice and easy to do. What's our y-intercept?
Plus 8.
Okay, if you're not sure where we're getting that from, we are substituting. So when we're looking for our y-intercept, x is equal to 0. So y is negative 0 squared plus 2 times 0 plus 8. So if you're wondering where that math comes from, that's what we're doing there.
When we found the shortcut ways.
Yeah, like it's right there. We
Yeah.
can just do that in our head. This is in standard form, so that's nice.
Yeah.
But we had to solve for vertex. So now we gotta do our x-intercepts. Okay. So when we're looking for our x-intercept, we know our y is 0. So we're going to have 0 equals negative x squared plus 2x plus 8. I have no desire to factor with a negative x squared. What do you guys want to do? Nah. I'm going to move everything to the left-hand side.
Oh,
Oh, come on. Oh.
Hey, at least you gave a suggestion. But again, if you weren't sure how to attack it, I would go to the quadratic formula.
Yeah.
Like, I would definitely do that. What the heck is that? Oh, I know what that is. Never mind. Okay. So do we have enough to graph this parabola right now?
the original one, yeah.
Okay, let's graph it. So let's put some increments on.
Ah.
Uh-oh. Anybody see my problem?
What?
No.
Anybody see my problem?
We need to go up to 8.
Who? We need to go up to,
10.
we need to go up to
Nine.
10.
Like 10.
Or 9.
9. I have the same problem, I just realized.
Oh. Each one will be, yeah. Each one will be 2. Now my little brain can't handle that, so I'm going to go negative 2. Oh, that's a positive 2. 4, 6, 8, 10, 12. Bless you. Okay. Oh, I still didn't do my top ones. 2, 4, 6, 8. 10. Oh, okay. I'm going to do my original in pink just because I can. I have 1 and 9. So my vertex is right there. I have a y-intercept at positive 8. And I have x-intercepts at negative 2 and positive 4. I think I'd like to do some points below the x-axis. Is that going to mess you guys up any? Maybe a little bit? So, like, we can connect them. But last year when I did it, people got all freaked out. So I want to do some points under the x-axis.
How would you?
Easy enough. Because I know if I go to negative 4, I'll have some point under the x-axis, right? So all I got to do, just like a table of values. So if I do negative 4, I'm going to sub it into the equation. What do I get? 16, negative 20, negative 12. No, I did that wrong. So I'm gonna have a negative 16 here, a negative 8, that's 20. Oh, that's negative 16. I can do that math all by myself. So, okay, that's not gonna be super helpful.
We don't have six, yeah, I was gonna say.
Okay, what about negative 3? What would negative 3 be? Negative 7? This is what I'm doing here. So negative 3 squared times by a negative 1 is negative 9. Positive 2 times by a negative 3 is negative 6. And then I just went 8 plus negative 9 is negative 1. Negative 1, negative 6 is negative 7.
I added this instead of
So if I look at 3, which is halfway, that's going to be at negative 7. What do we know about a parabola?
Gotta be the same on both sides.
Right, so if this one's 5, because I'm 1 away from an x-intercept here, if I'm 1 away from an x-intercept here, I'd be at 5, negative 7 as well. Woo. Mondays. It's a good thing I use a erasable pen. Okay, not the worst looking parabola, definitely not the best looking parabola I've ever done. All right, what do we know about the y values when I flip to an absolute? What do we know about those?
They flip the positives.
They change to positives. So what happens is all this can't exist so that's just why I did 2 points, so we actually have points to flip up. That's why I did that with purpose. You don't actually have to do it. Okay, so this 5, negative 7 becomes 5, positive 7. And negative 3 to 7. Looks like that. So my whole absolute is the whole thing, is the W.
Wait, what'd you do the other one for? You put on negative 2 and 7? Oh, negative 3 and 7, I see it.
Negative 3 and 7. Does that make sense? I just took those arms and I flipped them up. So that yellow graph is the absolute graph. Okay, what's the domain? Okay, do you guys need a second? Sorry, I'm rushing you. We got tons of time. Jatin's frantically writing. You good? Okay, so what is the basic domain and range for this graph? So for the whole thing, what's the domain of this graph? What's the domain of any parabola?
negative 8 positive.
Because this can go on forever as it gets wider and further out. What's the range though? Remember, I'm just looking at the yellow graph.
0.
0, inclusive of 0.
Infinity.
Okay, good job, everybody. All right, now we're going to do the piecewise. I always, sorry?
Why is it called piecewise?
Because you're breaking the graph down into pieces.
You mean wise about the pieces.
Shh. Sometimes we are. Sometimes we're holding on for dear life. All right, so I always start with my absolute, but let's start with the absolute. What parts of this graph did I flip?
The 2x intercept. Well,
Okay, I refer to them as the arms or the hump. So did I flip the arms or did I flip the hump? Okay, I flipped the arms. How many arms do I have?
2.
So you will have 2 domain statements about this. So we're gonna look at our left arm first. Okay, what's the domain statement for the left arm?
Negative infinity,
Brilliant.
positive infinity.
Nope, there's a hump in the way.
Oh, yeah.
Where do I stop? Where does the blue turn into the pink?
8.
-2.
So
But why -8?
I don't know.
I think you're looking, remember domain statement is about the X, what's happening on the X, right? So where does the blue stop?
Yeah.
It stops at the X-intercept, and the X-intercept is at -2.
Yeah.
So it is a domain statement, so we're just talking about the X-axis.
Yep.
In grade 12 calc, not pre-cal, but calc, we do limits that talk about what the Y is doing. Just so when you think you've got it down, I will talk to you about limits. Okay, so piecewise, we said we're going from negative infinity to -2 round bracket, because it doesn't include that. That's your left arm. Okay. Let's talk about our right arm.
Negative infinity.
Nope. Where is it starting? Where does the blue arm start here? Yes, it starts at 0 on the Y, but I'm doing a domain statement, so where does that start on the X? 4. Round bracket 4. Where does that arm go to when I'm talking about X's? Infinity. All right. Oh, sorry, you guys can't see that. So this is my right arm. Would you guys agree that they both belong to the graph? Your left arm and your right arm both belong to the graph. Yeah, not nice to only have one arm. So in math, when we want these two things to happen at the same time, we use unison. It's the letter U with no stick. We don't have time for sticks on the U's. So all this means is that those are happening on the same graph and they both belong to the absolute. All right, let's talk about the original graph. So this is the pink part. It's the hump. So domain-wise, where does my hump start? All the numbers on here are going to be your x-intercepts. So what's the lowest value of the hump? -2. Square bracket this time. Where does the hump end? +4. So I like to refer to them as arms and humps. Do what you will, call it what you like. This is because I use the arms here because we flipped the arms up. Sometimes you may flip the hump up. So then how many humps do you have? You only have one hump. So the one domain statement would go under the f of x, the absolute f of x. It takes practice. You guys will get all the marks for the graphing because you're solid at graphing quadratics. What will cause some problems is this domain statement. You just got to practice it and ask me lots. Is this right? Does this make sense? I think the answer key did the piecewise in set notation, fancy brackets. So that might be hard to read for you. And if you're not sure, then ask. I can translate it into interval notation. Okay, humps and arms, you're golden.